These two angles are vertical angles, which means they're equal to each other. So 5x plus 5 is equal to 7x minus 35. If I move the x's to the right and the numbers to the left, I find that x is 20. And that's what they want to know. Since J and K are parallel and L and M are parallel, we have some transversals here. So there's these relationships that persist across the different angles, and they want to know what is x, and the answer is 40. The length of line segment BC is 2 times the length of line segment AB. So I could describe 20 as 2x. So I might write that as 2x is equal to 20, and pick D. We have some parallel lines, L and M, and S and T. So if 1 is 35, that means all of these are 35, which means that the other angle has to add up to 180. So that's going to be 145 in every spot. So if RT is equal to TU, then we're looking at an isosceles triangle. So the base angles are the same. And all these angles have to add up to 180. So 114 plus 2 of the base angles is equal to 180. I subtract, I divide, and that tells me that this angle is 33 degrees and this angle is 33 degrees. I can also recognize this is a linear pair. Since one side is 114, the other is going to be 66 because they have to add up to 180. I can also recognize that the interior sum of all the angles of this triangle is 180. So 31 plus 66 is equal to, some number plus 31 plus 66 is equal to 180. That tells us this angle is going to be 83, which is vertical with this one. So finally, I know that 33 plus 83 plus whatever x is 180. This combines to make 116. If I subtract, I get 64. Because this figure has 4 sides, the interior sum of the angles is n minus 2 times 180, or in other words, 360. So I can take my different values like x plus 90 plus 2x minus 5 plus x plus 35, and I set the whole thing equal to 360, which is A. These are parallel and these are parallel, which tells me it's a parallelogram. So this is 115, and these are 65, and this is also 65. We're told too that CD and CE are equivalent, which means it's isosceles. So if this is 65, then the top angle right here is 180 minus 130, which is 50 degrees. And if I want to find BCD, I'm going to add those two angles, 65 plus 50, and there's my answer. So L and M are parallel. This one's 20, this one's 60. This is also going to be 20 because they are corresponding. So if I want to find x, I can take 180 minus 60 minus 20, and that gives me x, 100 degrees. If you remembered that exterior angles like this are equal to the sum of the opposite two, you can find out right away that y is equal to 140. Otherwise, you just take 180 minus a couple of times because the interior sum has to be 180, and this is a linear pair. If you do that, you'll figure out that this is 40 degrees over here. Now, it's very tempting once you find 140 to pick the answer, but they want to know the value of y minus x. So we're looking at 140 minus 40, which is 100. So if this is 100 degrees, I can figure out this into 60 because the interior sum of all three has to equal 180. And this is a vertical angle, so it's also 60. And now I have 60 and 40, so y is 80 because they have to add up to 180. So I know that this is x and this is x because they are vertical angles. So this missing angle here, which is also going to be y, is going to be equal to 180 minus 2x. C. So this formula tells you the number of sides and the exterior angle A. They want to know if this exterior angle A is greater than 50, what's the greatest number of sides it can have? So there might be a more precise way to do it, but we can just plug in some different numbers of sides. If you plug in 6, that's above 50. If you plug in 7, that's above 50. If you plug in 8, that's below 50. So the answer is 7. Since this is 90, and this whole thing is a 180 straight angle, I know that x plus 2x plus 2x is equal to 90. Or in other words, 5x is equal to 90. But they want to know what is the value of 3x. So if x is 18, don't pick that one, multiply it by 3. Multiply by 3 and you'll get your answer 54.